This is Dr. Maxwell, and we are ready to start Chapter 7. We're only doing a few things in Chapter 7. This material is from Section 7.1. So, what we're doing is talking about linear equations in two variables. Some of you will be very familiar with this sort of an equation, the equation of a line. We're going to go over the rectangular coordinate system. The XY plane is what we often call it. We'll find solutions for equations like this. We'll graph equations like this. And we'll talk about how to recognize lines that go through the origin and what does that even mean. How to recognize a vertical line and a horizontal line. And we will not do this. And we will not do this. So that's it. So let's consider this equation. Notice now we have two variables. Up until now, we've only had one variable. Now we have two. So a solution to this equation needs to contain two numbers, one for x and one for y. So we call this an ordered pair because it's a pair of numbers, real numbers, and it has an order to it. We always put x first and y next. That's alphabetical, if you ever forget, isn't it? Alphabetical order, x, y. So a solution to this equation is a pair of real numbers that satisfies the equation. So how would we find a solution to this equation? And another question to think about is how many solutions are there? Well, one way to find a solution is to start somewhere. Let x equals 1. Then what does y have to be? Well, then y equals 3. Plug in 1 for x plus 2. So y equals 5. So that gives me my ordered pair. When x equals 1, y equals 5. Now, this is a solution. Why is it a solution? When we substitute those numbers into this equation, the result is a true statement. Let's try it. Remember which is which. Does 5 really equal 3 times 1 plus 2? Yeah, when we substitute these in, we get 5 equals 5. That's true. So that's what makes it a solution. Put the numbers into the equation, see if it's true. Now, let's find two more solutions. So a lot of times we're going to choose values for x. So let's let x equals 0. That's always a good one to use. Then what? Y equals 3 times 0 plus 2, which means y equals 2. So there's a solution. X equals 0, y equals 2. Now pick another number. Maybe pick a negative number. Let x equal negative 1. So put negative 1 in for x. Then y equals 3 times negative 1 plus 2. So be a little careful here. Y equals negative 3 plus 2, which equals negative 1. So when x equals negative 1, y equals negative 1. And you can always check. Let's check this one. Let's check it. Put in -1 for y and ask yourself, does this really equal this when we put -1 in for x? Well, the left-hand side is -1. The right-hand side is -3 plus 2. That's -1. Yes. So we could do this for every single value of x on the whole number line. You pick any value on this real number line, let x equal that number, and then you determine what y is. So there are infinitely many solutions. Since there are infinitely many solutions, we cannot list them. So how do we show the solutions for this equation? Well, the solution set, all the solutions in the solution set to this equation lie on the line that is defined by this equation. The graph is a line. And we call this a linear equation. One reason is because the exponent on x is a 1. It's a first degree polynomial. And another reason is because the graph of the solution set is a line. Okay, here's another example. It's a linear equation in 2 variables. And oftentimes you might want to set up a table. So let's just talk about what they're doing here. Here, they've chosen these values of x. When x equals -4, they plug it in here, and they get the output of y, which gives me this ordered pair. For example, let's do this one. Let x equal 4. Then what does y equal? Well, y equals 2 times 4 minus 5, which means y equals 8 minus 5, which is 3. And that gives me this ordered pair here, 4, 3. So sometimes this is useful in some applications. So you should just know what's going on in this table. This is how to get 1, 2, 3, 4, 5 solutions to this equation. Of course, a table cannot show an infinite number of solutions. So we like to use a graph to display all the solutions. And we have to graph it in our very familiar, what I call the XY plane. And we're going to review how this is set up. This is the rectangular coordinate system. So, some very basic things here in case you've forgotten. The vertical axis here, vertical, is y. The horizontal axis is x. So that's important to keep straight. When you have this ordered pair, x, y, let's see, let's just take one, well, I'll just make one up. Suppose we're looking at the ordered pair 4, 3. That means x equals 4 and y equals 3. Let's do x in red. 1, 2, 3, 4. So this dotted line here represents all the values where x equals 4. Now y equals 3. That's the vertical line going through y equals 3. Right here, where that intersects, that's the point 4, comma 3. These are like directions. Go to the right 4, go up 3, and that will be my point. And we'll do some more practice with that in a minute. But so we have two axes, the X and Y axes, and it's useful to understand this notation, quadrants, in this vocabulary. What's a quadrant? Well, and let's say a little bit more about X and Y here. What are these? X, this is just the real number line. Down here is negative infinity, here's positive infinity. Y, this is also the real number line. It's just a second copy, positive infinity up here, negative infinity down here, and these are at right angles. So this gives us basically a map. Every point on this graph can be described by its X position and its Y position. Every point on this graph has directions to it in the form of an ordered pair. And so we like to talk about quadrants. So we have our two copies of the real line, X and Y, and that divides this plane, a plane, not an airplane, a plane like a flat surface, into 1, 2, 3, 4 quadrants. Notice that we go in a counterclockwise order to talk about them. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4, and we use Roman numerals. That's just convention. But if I say something about quadrant 3, you need to know that I'm talking about what? What am I talking about if I'm talking about quadrant 3? I'm talking about some point down here in this quadrant. Both X and Y, whatever point you're looking at down here, the X coordinate is going to be negative, isn't it? And the Y coordinate is going to be negative. Do you see that? Maybe it's not clear because what is this here? Where do they intersect? They intersect at the point 0, 0. So here on this side are positive values of X. On this side are negative values of X. For the Y-axis, up here, we're talking about positive values of Y. Down here, we're talking about negative values of Y. Okay, this is an important vocabulary word. This point right here is very important, and it's known as the origin. That's the point 0, 0. That's where the X and Y axis intersect. And all these points have been plotted. Let's just talk about a couple of them. So what does this mean? The point A, X equals 3. There's 3. Y equals 2. There's 2 on the Y-axis. Where these intersect, that's the point 3, 2. Another way to look at this ordered pair is this tells me to go to the right 3 units and go up 2 units. So if I go to the right 3 units and up 2 units, I arrive at my destination, point A. So let's look at point D. What does it tell me to do? It says go to the left 3 units and go down 5 units. So if I go to the left, let's use a different color, 5 units, and then go down, oops, I'm sorry. How many units do I want to go to the left? 3. Go to the left 1, 2, 3 units and go down 5 units. I arrive at my destination, point D, where x is negative 3 and y corresponds to negative 5. See here, this would be negative 3 right here on the x-axis. So hopefully this is all very familiar to you. If you have any questions about this, please ask right away. You look at this point, what does that tell me? X equals 5, y equals negative 2. So here's 5 on the x-axis, here's negative 2 on the y-axis. And just try to keep it straight. X is the horizontal, y is the vertical. Okay, so here's some more vocabulary. Coordinates. So if we have an ordered pair AB, say it equals negative 2, negative 4, the coordinates of this point B are negative 2, 4. That's just vocabulary. This is called what? This is the x coordinate. What is 4? This is the y coordinate. Just gives us a way to talk to each other precisely. Now, so sometimes this rectangular coordinate system is called the Cartesian coordinate system, or simply the Cartesian plane. And if you think of this word, Cartesian, maybe you think of maps. If you've studied any French or just a cartographer, people who study maps, I don't think I can spell that off the top of my head. But this came from the study of coordinate geometry. And this is just a little bit of extra information that I think is interesting. Who came up with this wonderful system, this wonderful Cartesian plane? Well, here's my hint. Have you ever heard this? I think, therefore I am. Do you remember who said this? And this is the punchline from some stupid joke. Do not put Descartes before the horse. Have you heard of this man, Descartes? Well, here he is, René Descartes, French philosopher and mathematician, of course, and very famous figure. And here are 2 quotes that I thought were good. It is not enough to have a good mind. The main thing is to use it well. Well, okay, you can like it or not. I like this one more. If you would be a real seeker after truth, you must at least once in your life doubt, as far as possible, all things. Question everything. Okay, let's pause here. And when we come back, because some of you might need to skip this section, when we come back, we'll talk about how to graph a line.